Hello everyone, I'm Thomas.
I'm Mehdi.
And we will be presenting you our work about Hadoop. First question is, in the room, is everybody ever known about Hadoop? Ever heard about Hadoop? Who, raise your hand, has already heard about Hadoop? Cool, that's cool, great. So, I have to warn you that this presentation is kind of verbose. There's a lot of content inside, written content, that it might be, you might have the sensation that it's overwhelming, but the thing is, we want, as speaker, to have our presentation readable and that people can understand it after the conference without our needs. So that's why there's a lot of content written inside. So who we are, basically some InfoSec auditors and incident responders. That's for our presentation part. So here's the agenda. First, we're gonna talk about the Hadoop and its security model, a brief overview. Then how to practically attack and assess the security of an Hadoop cluster inside in a corporation, in enterprise. And then some few conclusions and how can you harden, attack and defend an Hadoop cluster. So let's start with the definition of Hadoop. Hadoop is an open source framework that allows for the distributed processing of large data sets, so-called big data platform, using simple programming models. So for the distributed processing, if you know about Hadoop, you know about the MapReduce algorithm, in order to, which was invented and designed by some Google engineers in order to sort and index web pages. Basically, you have a map function that generates key value, intermediate key value pairs, and a reduce function in order to sort and to aggregate similar data. For the open source aspect, Hadoop is totally free and open source, but in real life you do have some distributors, just like Linux distributions. You have three main vendors, so Cloudera, Hortonworks, and Mapper. The common point between all these distributions is the usage of the Hadoop core framework. We will see just after what's inside the Hadoop core framework as a base for storage and processing. Hadoop, if I can sum up what is Hadoop is just storing and processing data. That's the two features, the main features of that product or solution. In real life, what does a real big data environment looks like? So first you buy a lot of CPU, RAM, disk. On top of it, you put the Hadoop core, the core components, in order to support the data lifecycle in the platform. Then you will see some different parts and different modules on this slide for different purposes. So the first purpose is to acquire and to make the acquisition of data inside the platform. So you have a lot of modules. Most of the modules you will see are free and open source, backed by the Apache Foundation. So for the acquisition, you have these modules. Then for the storage, as a core component, you have HDFS, which is Hadoop Distributed File System. Then for the processing, that's another main feature of Hadoop. You have a lot of modules. The most known today are maybe Spark, Drill for SQL request, Pig, Impala, and so on. Then you index some data. So you have, I guess you know Elasticsearch, Solar. For the consultation, for the end user, you have different modules, non-different modules, which are Jupyter, or formerly IPython Notebook, U, Tableau, SAS, and some other solutions. For the administration, each distribution has its management platform portal. For Cloudera, you have Cloudera Manager. For Hortonworks and open source stuff, you have Apache Ambari. And Mapper has its own platform also. For security now, you can see that there's really few modules compared to the other phases of the data management in the platform. So today we will be talking about about Apache Ranger, few words on Sentry and Record Service, and few words on Nox. So Hadoop core under the hood. So briefly, so as you may remember from 2 minutes ago, so store and process So for the storage, you have two types of nodes in a Hadoop platform. You have some data nodes holding some actual file parts on HDFS, and you have a single active name node storing a list, a mapping list of file parts and their data node location. The name node knows where you can download all the parts for requested file. Then for the processing, you have so the MapReduce algorithm, which is quite simple, and you have Yarn, which is the scheduler on the cluster. Really complex. This is almost like an operating system. This is the Hadoop operating system, which is a bit complex, and there are some words to put on about on security for this module, but this is not the point today. We will not be digging into Yarn, but this is a core component of Hadoop. Right now, you can say, yeah, Hadoop is cool. I heard or I never heard about Hadoop, but who really uses in the real life? So, as you may understand and see here, web giants, major web companies are using Hadoop in order to process their large amount of data. Adobe, Criteo, which is a French company doing advertising, eBay, and Yahoo. So now the security model by Mehdi.
So now that you master the Hadoop core, let's talk about security. So first feature you want to talk about is authentication. So by default, Hadoop comes with the simple authentication activated. What is simple authenticated? In fact, it's not really authentication, it's just identification, because in fact you just pass your name to the Hadoop cluster, and the Hadoop cluster answers you back if you are a real Hadoop user. So if you know the name of a Hadoop user, which is, for example, HDFS, you can be HDFS just by passing this string. So there is another mode, authentication mode. It's called Kerberos, the MIT Kerberos authentication model, which is the only proper authentication mode on Hadoop. So remember, simple authentication is not authentication. Real authentication is like more identification. So we can be whatever we want, which service you want. So if you really want to implement authentication, you have to implement Kerberos, and it's more complex than just using the simple authentication. So be careful. Authentication is just to enable Kerberos, you have to use the Kerberos mode on many services. So, for example, if you just implement Kerberos authentication on the core model, you will be able to access the HTTP services without authentication because you didn't activate Kerberos authentication on this service. So, for example, you have several, like on this one, you have the Hadoop authentication, which is the core Hadoop. Then you have the Kerberos authentication mode on the web interface. Then on the other web interface, etc. And you can, so you have to implement this authentication on every service on Hadoop. So next, authorization and auditing. Like Thomas showed before, there is a lot of services on Hadoop, and every service implements its own authorization and auditing model. You have, for example, on the HDFS, which is the file system on Hadoop, which implements the POSIX permission model. So, like on Unix, you can give permission to user, group, and other people. So you can, like just on Unix, set the permission. You have also the extended SAL, like on Unix too. So since the Hadoop 2.5. Next, you have, for example, Hive, which is SQL-like DBMS on Hadoop, which allow authorization on SQL verb. So it's another kind of authorization model. So in order to be able to to manage this authorization model on all your cluster and more easy. So you have to use the third-party components, like, for example, Apache Ranger, which is for our research the best third-party module for this purpose. And then you have also Apache Sentry. Then let's talk about encryption. So data protection. By default, there is no encryption implemented on Hadoop, activated, sorry, because encryption is implemented, but you have to activate it. If you didn't activate Kerberos, so for authentication, you can't activate encryption. So for the encryption in transit, you have different type of level on the RPC chain. So you have just authentication, which is you just authenticate your stream. Then you have integrity, so you can just prove the integrity of the data and the authentication. And you have the privacy mode, which is full data protection, which is encryption, integrity, and authentication. Then to access the HTTP interface, you can enable SSL TLS, which is natively offered by Hadoop, but which is not activated by default. Next, we have the communication with the data node, which is called, which uses a protocol called DTP, which use 3DES or SC4 for key exchange, and encryption, which use AES by default. Next, you have encryption at rest, so in storage, which use different type of key. You have the encryption zone key, which is used to encrypt the directory, and you have another D key, which is used to protect the first key. So the scheme is this one. So you have the KMS, which hold the key, the client, and the name node. In fact, I will not dig into this model, but the real problem is that all the security is not on the crypto system, but on the security of the KMS, because it's the KMS which hold the key. So if you can just crack the KMS, you can take all the key and decrypt all the data. So remember that. So then let's try to attack an Hadoop cluster. So first, we want to map the attack surface. So let's, like Thomas said, and me before.
Thanks. So from our experience, the first thing when you encounter an Hadoop cluster is to know in which topology you are. From our experience, we have seen 3 different topologies, giving 3 different security levels and 3 levels of complexity, which you can say for defenders. So the first is the simplest one, which is the odd expose on the corporate network. So you have everything from the Hadoop infrastructure exposed on the corporate network, on the flat network. As you can guess and understand, this represents a wide attack surface, and it gives attackers a wide and a high probability to illegitimately access data and resources. Then you have a better topology and better design, which is the only necessary end-user services exposed, mostly web applications, and also the edge node. What is an edge node is like a jump server or bastion for entering the Hadoop infrastructure. Not every user needs to access the edge node. A lot of people need to access only web application, which are, remember, for data consultation. And then the internal Hadoop infrastructure is masked from, is hidden from the corporate network and just accessible only for the edge node in the web application. As you can guess, the attack surface is really reduced, and an attacker should exploit trivial or default or unpatched services on the following server, to enter the Hadoop world. This is a bit better. And far better, you have the highly segregated model from the corporate network. So again, it looks like the second one, but there's another layer of protection for security reasons. And even to enter the edge node and to access the web apps, you need to access a Citrix or a real Bastion, a real jump server, a real solution. This is the highly segregated model. As you can understand, the attack surface here is really minimal because you have to go from the Citrix or Bastion, which you can secure, which is another security topic by itself, and then you only access front-end services. And then, if you want to access data node and name node, you can have some restriction, network restriction.
So, if you try to perform a network scan on the Hadoop cluster, which is not really well filtered, network filtered, you will find a lot of service. You have like some IPC service used by the core Hadoop services. You have some HTTP interface, etc., which is used by user to manage the job, to just browse the HDFS, etc. You have also other services on data node, which are mostly the same that on the name node. They are just other web UI, but it's all for the main purposes. And then you have some third-party module, like we already told, like Nox, Apache Ranger, etc., Cloudera, which are used to manage the cluster. So, for example, on the name node, you have some interface like that. You can browse the directory, you can browse the HDFS through the web interface. So you can just put the path is here and just check the file and you can download it. And you have similar interface on the data node, which is pretty old and ugly, but which is used for the main purpose, so browsing the data lake. Then you have all other interface related to Yarn used to manage the job, so you can view the job history, manage the job which are launch, running, etc. So that's old interface. So you have a lot of web UI which are not really used by real data scientists, but which are very often accessible through the network. So in order to perform the scan and to ease the task of the pen tester, we developed some script in order to be able to detect which service are running on this port. So we have the script called HTTP enum which is usable with Nmap, which is used to detect Ambari, Uzi, Ranger, etc. So the output is like this one. So you have clearly the name of the service, the name of the port, the number of the port, and that's all. And then you have other scripts developed by other pen testers, which are usable in order to, with Nmap, in order to detect and to improve the detection of the service.
So right now, let's move again more practical stuff. So as a big data attacker, what do you want? You want some data. That's very easy to understand. How you would like to access it? Through a browser, because you're a lazy guy like us. And so how do you want to access? So there's one protocol to rule them all, which is WebHDFS. As you may understand, WebHDFS allows to access HDFS through web interfaces. You can do everything you want and almost every action on WebHDFS that you can do with a native Hadoop client. Where can you find some WebHDFS services? So on the data node, on HTTPS module and Apache Nox gateway, which is only a true gateway exposing some stuff, not reinventing the wheel and so on. Apache Nox exposes the same stuff as HTTPFS and finally HDFS data node. So, okay, now what if the cluster only enforces simple authentication that you can enter and specify a user.name parameter and specify the username, the user you want to be. This is the simple authentication. This is a strong point from our presentation. Disable and put Kerberos and remove that that freaking simple authentication. So specifying the user.name is not an attack. This is just a feature. There we have some demo. I will just show you some stuff. So how concretely you can access some stuff.
So first, like Thomas said, we try to access the cluster through our browsers.
So here I'm making a request, as you can see, in order to access that path on the distributed file system. List status is just to give you some information. You have other operations like open, close, remove, and so on. Here, it is saying that I'm Doctor Who, and I don't have the right to access that folder. That's not, again, if you already understood, that's not a problem because I can specify which user I want to be. And here I can access the data just by specifying. This is not an attack. This is just how what's the outcome of enforcing only simple authentication. And that's it for the moment. From the Hadoop with the Hadoop web client, native client, sorry, you can also use that same kind of command here just to access the data and just print the content. Yeah, let's hope to be working. So here again, I'm root, so I don't have any rights. I'm not the correct user and the right user to access it. I just specify the user like this. And here I can access the data. This is not an attack. If you just understood, this is just simple authentication. So to ease this task for the pentester, we develop a dump script, HDFS browser, in order to enumerate and to list all the content. And this is the same part here. I just explained it. If you want to access it through the native Hadoop CLI tools.
So, okay. So with the attack that Thomas just showed, you can just steal the data from a cluster. That's cool. That's a big thing. But we want more. We want like execute code. We want to own the cluster. So remember, Hadoop is used to process data. To launch code in order to be able to pass the data on the cluster. So it's used to execute code. Then we see that with simple authentication, in fact, you can just get the data, but you can also just submit some job in order to, for example, count the word in files. Remember, Hadoop was developed in Java, so by default, or more likely, we don't want to use Java in order to execute some code because we don't really like this language. So we are not the only people like this. Some other developer just build a feature called Hadoop streaming, which is used to just execute any kind of script, like Python script, Bash script, etc., on the cluster. That's easier than Java. So let's talk about this feature. So you have the Hadoop command line, so it's the Hadoop clients. You just put the jar option, and then the path to the Hadoop streaming jar, which is always installed because it comes with the default Hadoop package. Then you put the input file, which could be anything but not an empty file because the output would be empty. Then you just specify the output folder, the mapper, which is, for example, beancat etc password, and then a reducer, none, because we don't need a reducer for this case. It's just an optimization. So this launched the MapReduce job. This is the command used in order to check if the job was successfully performed. So you just check the output, and then you can just cat, like on Unix, Linux, the output file and retrieve your data. Okay, so that's cool. We can execute some code, but we want to perform this easier, because like we say, there is 3 steps. It's not really easy. So we just want to execute some code using, for example, Metapreter and Metasploit. So we tried to put some reverse TCP payload in our payload. So we first generate the payload, the reverse TCP, using MSF Venom. So we just specify our IP address, the format of the binary. Then we launch our listener. Then we just type the Hadoop command, which is mainly the same that the first one, which is just we just specify the file option more, which is used to upload our MSF payload generated by MSF Venom on the cluster before executing it. Then you have also to specify the background option, because if you don't specify this option, the job will shut down after a timeout. So we want a persistent shell. We don't want the shell to stop when we are executing some command. So this uploads the local file on the HDFS, and then this stop the timeout. So demo time.
So this demo can take a lot of time, so we'll just be launching it. By chance, if we have the shell quickly, that would be cool, but that's not really a problem. We can wait. So here we just prepared, this is not a big deal. We just prepared the reverse TCP handler, and here I'm just launching with that command. So Mehdi just showed you. I'm just using the Hadoop streaming stuff, specifying some option. Giving the mapper the output of MSF Venom, uploading our file with the file option, and giving the background option. So we'll just be launching it. Hopefully, it will take not a big amount of time. We just check. So on the PuTTY screen here, this is just on the server side, just for our presentation to monitor if everything goes right. Obviously, as an attacker, you don't have this kind of access, you cannot monitor, but this is just for demonstration purposes. And hopefully here, our shell will arrive in 2 minutes, because this is another point. You may think big data is quick and fast and everything. No, big data this is a pain, slow. This is Java, this is a lot of slow stuff. You will see it, but the thing is, with big data, you can process a lot of amount of data. So we'll continue the presentation, and just in a few slides we'll switch back to the demo to see if our shell arrived.
Exactly. So we just presented some method in order to retrieve the data using the Hadoop clients and to execute code, but using also the Hadoop client. But we didn't talk about the prerequisites, which are very important. So in order to be able to execute this code, you have to retrieve the configuration of the cluster in order to be able to talk with the server. So to retrieve this configuration, we have different methods. First of all, and I think the more useful, is to check the /conf on every web UI. In fact, we don't know why, but on every web UI, if you tap /conf at the end, you just retrieve the configuration. And if Kerberos is enabled, and if you didn't enable Kerberos on this HTTP interface, so any user can just retrieve the configuration. Or you can just exploit some vulnerability like this one. You can just, on Cloudera Manager, which is used to manage the cluster, you have a vulnerability. We found a vulnerability in order to be able to retrieve the configuration with an authenticated attacker. So next, we have developed in order Hadoop Snooper script in order to ease the work of the pentester in order to retrieve the configuration automatically, a minimal configuration. So this is the output. This is the command line of Hadoop Snooper, which is available on our GitHub, and this is the output. You have the yarn sites.xml configuration file.
So you may think that that's cool, you develop some script, but really in real life, who exposes such services? So on Shodan and so on, you can find a lot of stuff. This is not big news. And some more interesting from a study of our own, we tried to see how many clusters are exposed on the internet. So, and which are the security authentication scheme implemented. So we found 185 cluster on the internet. You can see the figures here. Among that amount, few clusters are Kerberized and have Kerberos. So, as you may remember, simple authentication is no security. So, all data on all these clusters are freely accessible. And more interesting for Kerberized cluster, how among these the 5 clusters found, how many are really using Kerberos end-to-end on every HTTP web interface? Answer, 0. That's some proper figures from our own study. And really, in media now, and there are some attackers performing some ransomware or just wiping attacks on Hadoop clusters. So this is not, from lab, this is from research or just lab. Some real people in real life are deleting and attacking some Hadoop cluster on the internet. So, let's go back to the demo to see if we have our shell. So, okay, we have our shell. The shell arrived, so the command get executed. You can see here. And right now, who am I? I'm yarn, the scheduler. So with just, if you remember the command sent, the MSF, the interpreter, we do have our shell. So as an attacker, you can perform, you can continue your attack and move on and do some lateral movement and so on. So cool, the demo worked. That's a good point. Then, another vector to attack and to assess the security of an Hadoop cluster is to use, and to exploit, intrasync Hadoop vulnerabilities. We found some for the next slide. So here you have what we call the HDFS Groups command vulnerability, valid for these versions, which are not really old, to be fair. You can find a lot of cluster vulnerable to this flow. And here the prerequisite is not really easy. On clusters having the shell-based Unix group mapping as the security group mapping property, this implementation is vulnerable to this flow, to this CV, because this function is called on each user action in order to retrieve user groups. And as you can see in the code, there's a vulnerability, nothing is escaped. And technically, so as an unprivileged user having access to an edge node or just a data node or name node or through SSH, you can elevate and perform a privileged escalation attack. You are unprivileged, you type the command HDFS Groups and something here, and as you can see, this is not escaped, and you benefit, you are then using and executing your code with the HDFS user, which is, remember, the root user and the HDFS component, giving access to every data on the cluster. PS, we are not the vulnerability finders. We just documented the exploit because nothing was really documented, even if Apache Hadoop is fully open source. So let's have a demo time. So here I'm just using, now that I do have access, this is here, more easy here. I'm just a dumb user, Toto, with no specific rights. And just to see how you can exploit this, I will just type that command, exploiting that vulnerability, just to see which real user am I. Here you will see that hopefully this demo will work. And here if I now cat here, that file, I am HDFS. So I went from Toto, no specific right, to HDFS. This is the exploitation of that vulnerability. This is really easy, as you can understand. You type everything after groups, you have your payload, and you are escalating your privileges.
And the code is executed more faster than when you execute the code on the cluster. So
yeah.
that
you don't have to wait. You don't have to wait for a payload to be executed remotely. So as shell-based Unix group mapping is apparently not the default value, so not many clusters should be vulnerable to this flow. This is right. But again, some figures from a study of our own on the internet. How many clusters are vulnerable to this? A third. Even if that parameter, if that property is not the default one, we still don't know why we can find that number of vulnerable clusters. Another kind of vulnerability is to exploit third-party modules. Do you remember the slide with a lot of modules for the data management in the platform, for acquisition, indexation, and so on? So let's attack the only security module, valid security module for Hadoop, which is Apache Ranger. So even if it is a security module, there are some security vulnerabilities. Here you can find an SQL injection we found. You have two interesting post-exploitation operations, either dump user credential, but passwords are hashed and you have to crack them. This is cool, but not really interesting. Or better, just dump user session cookies, which are stored in the databases, and reuse them because you don't have to crack anything. And here you can spoof, the admin, standard user, ranger, user sync, and so on. This is more easy. Another cool vector for your pen test on another component, which is Cloudera U, massively used and maybe the mostly used component for end user.
Yes. On every pen test we have performed, we found this component called U, which is used by administrator, but also by data scientists in order to use the other components like Pig, Hive, etc. It's a HTTP interface which is used, yes, in order to manage the other component.
Tu veux faire la démo?
Yeah.
Tu veux que je la tape?
Well, yeah. Yes, so when you can execute code on the cluster, you can just first try to find the U file configuration file. So you just type, for example, find /-name u.ini, and you just found that by default, this file is readable by every people on the cluster. So if we cat that file, we will find that there is a lot of stuff inside, configuration stuff, and for example, the default database password, the LD password, etc. So you can just steal the LD credential, but also the database credential. And inside the database, because U is based on Django, it's U and Django stores all the session cookie on the database. So you can, like on Ranger, just steal the cookie of the administrator, for example, and just reuse it in order to be the administrator on the web interface and just to own you.
If I can add a word on this point, is that most of the time an edge node is deployed for end user, and most of the time we don't know why Cloudera U is deployed on that, that edge node, which is just a jump server. And this is a design flow because, as you may understand, with this kind of vulnerability, real users have access and SSH access to a server, which is just a client, and is just exposing some other application. So with this kind of vulnerability, so every user on the jump server can access the configuration file and see the password. This is the design flaw coupled with a vulnerability from you for the right misusing.
So just like the example, you can steal database credential, and then you can just steal the password hashes or the session cookie.
So you have to understand that we reported this kind of vulnerability to Cloudera a few years ago, few months, a dozen of months. No official answer, no fix. So this kind of vulnerability is still valid. As a mitigation, maybe Mehdi can say what you can do in order to mitigate this kind of vulnerability.
In order to mitigate this vulnerability, you first does not have to install U server on the edge node, which is a node on which standard user can just connect on using SSH, and you have obviously to change the permission on this file. So that's the two main recommendation.
And last but not least, our most elite attack to get some legitimate access is a simple find command. So with this command, I guess you understand it. You want to find all kitab, Kerberos kitab, with read for other permission. And in real life, it gives you a lot of output. From our experience, every time we get a lot of access, being a single user with no specific rights, you collect a lot of kitabs, and so you collect and you sum the access. In real life, it gives you that kind of figures.
This Monday, I was performing a pen test on the data cluster, and I own this cluster just by using this command. So that's a real issue, and you should really use this command in order to pen test the cluster.
Yeah, and don't forget that you can find files on local storage and also on HDFS, because HDFS is a storage, distributed storage. So people will misuse and put a lot of crap data on their home directory, on local system, and also on their HDFS home directory. So as a mitigation, you have to prevent potential permission misuse by users, because people will and do misuse some rights. People that are not really aware of this kind of attacks and how Kerberos works and how Kitab works. So to prevent this, please try not to make them Unix owner of their home directory, and use this is not a simple action, because there are some administrative stuff to put in place for this, but use some POSIX ACL to grant them read write execute in their home directory, but not making them owner, because with this tiny trick, even if they try to shmod and to put some read for other rights, if they are not their owner of their directory, no other people could access and could traverse their directory. And most importantly, tell people that a Kerberos kitab is like a password file, no read for other. This is like an SSH key or a password file. You don't have to, or a toothbrush. You don't have to share it with anyone. And this is really the same for Kerberos kitab.
So, if you want to help us and to join us in our Hadoop Safari, you can just start by downloading one of the default package, Hadoop package. You have Cloudera, which use the Cloudera Quick Start package. You can just download the VM and launch it. That's the VM we used for our demonstration. You can use also Hortonworks or Mapper Sandbox. If you want to download our tool, they are available on our GitHub at this address. We can find our tools, but also a lot of content about Hadoop exploitation and Hadoop pen test. So we try to make it the clearer we can and the best we can. So if you have an issue with the tool or if you want to add something, do not hesitate and just open an issue on GitHub.
Yeah, and on this repository you can find some tools, and most importantly you can find some methodology. How step by step how you can assess everything we said today, but even written with real words and not just only vuln and exploitation and scripts. So we have like not a book but not real article. So on the methodology how you can do it, and you can find here also on this repository vulnerability details and exploitation details. So some few conclusions. We tried so the repository is named, Hadoop attack library. Maybe someday we will be doing some Hadoop defense library. But in the meantime, what are the conclusion about Hadoop security? Because this is the point of today. So Hadoop is a technology not built upon security. This is the case. There's a lot of insecurity by default. Simple authentication, which is anything except authentication. There's no encryption. Then you have a fragmented ecosystem, just like Linux, Android, and so on. This is too bad for security, because even security solutions may not be available for your distribution. If you have, this is as of today, if you have Hortonworks, you can have Apache Ranger. It comes prepackaged. If you have Cloudera, a Cloudera cluster, you don't have you don't have Apache Ranger prepackaged for your environment. So this is a shame for security. There's a lot of immaturity in secure development, as you can see. Even in security modules, Apache Ranger, there are still some security vulnerabilities, some dumb security vulnerabilities. And a complex operational security because of the version shipped with distribution. And more importantly, because users do and will misuse Kerberos GitHub. So if you understood our presentation, at the beginning you don't have Kerberos. So the first step is to put in place Kerberos, which is not something trivial. And then you have to perform some awareness to the user, not to misuse Kerberos GitHubs, and not to grant them read for other permission, because it will constitute a hole in your Hadoop Kerberos plan.
So to conclude our talk, we propose some recommendation. So first, and I think the most important, just Kerberos your cluster. If you don't have Kerberos implemented on your cluster, you know the security level of your cluster, it's nothing. So just Kerberos your cluster if you don't want anyone to own you. Then reduce the service exposition, because like we showed you, the more you expose your cluster, the more you are vulnerable, and the more the attacker have attack surface in order to attack your cluster. So filter, implement network filtering. Then don't give free shell, because you know that Hadoop is used to execute command. Just grant to user we have to execute command on the Hadoop. Don't give free shell to, I don't know, data scientists. We don't need it. Then try to deploy application on edge node. Don't, because we want to reduce the service exposition. We want to deploy application on the edge node, because if user have also access to edge node, they can just, for example, read the u.ini file. So don't deploy application on the edge node, except I think the Hadoop client. Then try to prevent and detect the permission misuse on Kerberos GitHub file. And last but not least, and I think the hardest recommendation, try to harden components and try to keep your cluster up to date. That's not really easy operation, but you have to do it if you want to to avoid any attack, because we know that there are often some new vulnerability on Hadoop, so try to keep up to date.
So that's all for us. Thank you.
Thank you for
we have plenty of time for questions.
Yeah, 10 minutes.
Any question? No question, guys? I guess that's it.
Thank you.
Thank you.
Thank you.